So, hello everyone. A little bit about me. Today we'll talk about RAG models, but especially about evaluation because, again, it's one of the most challenging topics in knowing if your large language model works. And recently there was a study that was done by Gartner, which is 30% of the machine learning or generative AI projects are doomed to fail, which is the companies will stop investing in them post the initial pilot testing within the companies itself. So not to say, okay, we're heading into not to make any doomsday predictions over here. I don't think it's that bad. But I think one of the reasons which could be a big significant factor in doing that is basically a lack of evaluations, which is people are deploying models just the way they are without really understanding if they're working well for your use case or not. So that's the presentation we're doing for the day. A little bit about me. I'm the founder of Abi Aryan. We're building something which you can think of as a second brain, which is it remembers things that you are currently working on, and it subconsciously stores some things in the memory. So that's what I'm working on. I've been in the ML industry for like last 8 years, deploying machine learning systems. So that's pretty much about me. Prior to that, I was a visiting research scholar at UCLA. I was working in intelligent agents, so very specifically in AutoML multi-agent systems and emotion recognition. Right now, I'm working on a book on LLMOps, which is managing large language models in production. So let's get to the presentation since we are running a little bit late today. Let me say this, which is LLMs are being used as general purpose models, which makes evaluating them a multidimensional problem. There are far too many scenarios that need to be tested. For example, let's say safety and bias, or grounding to avoid hallucinations, or even efficiency. However, defining what good really means for a large language model is really hard. So there have been a couple of studies, most of them are like, AI has really like a measurement problem. How do we make sure that it's good? That's the big question. But in terms of defining the good, that is very, very complicated. Reason being, first, you're thinking about the task-specific goodness, which is it has to perform well on the task you're giving it. Then it has to work really well on your custom predefined metrics. And thirdly, basically on the frameworks and the existing libraries that you're using to automatically evaluate your model on. And finally, obviously, on human evaluation as well. So evaluating good in each one of these categories requires us to look for different goals and different metrics. These metrics can be dataset, these metrics can be leaderboards and benchmarks. And I know I'll come back to this question of benchmarks eventually. But each one of them has their own limitations. For example, human evaluation, super expensive, time consuming, despite the fact it's the gold standard. Benchmarks, most of the benchmarks are at this point pretty unreliable in the sense that they have been reverse engineered. Most of the data is included in the pre-training data set itself. So again, not super reliable. And when it comes to using large language models as evaluators themselves, again, they can be biased, opaque, and very resource intensive. So I'll talk about 3 things today, which is first, why evaluation is hard. Second is we'll go into like a systematic framework for evaluating large language models. And finally, we'll talk about the open challenges. So why evaluating large language models is hard? Like I said, it's a multidimensional problem. You're looking at the model performing very well across all of these things, which is across informativeness and factuality, across it should be fluent, it should be engaging, the model should really be biased. The model has to be efficient in terms of the computational resources required by the model to be able to generate outputs, which is basically the inferencing itself. When it comes to now, even if you've defined the scale, which is once you've broken your problem down into all of these dimensions, next thing is understanding what's good. So Good, like I said, it can be the task-specific success, it can be the accuracy and effectuality, it can be relevance, it can be informativeness, it can be safety and fairness as well, and efficiency once again. So these are the metrics where different companies would have to sort of define their own what's good enough. And that is the big problem, really. So as of now, basically, there are three categories that I divided the LLM evaluation criteria in. First is anything to do with the language itself, which is evaluating the core features of the language, which is the language features, the task independent, task dependence. Then the next thing is evaluating the models on the basis of certain metrics. So these metrics could be quantitative metrics, so measures of performance. These can be LLM specific metrics if you're using large language models to be able to evaluate your model itself, or these can be custom metrics that are defined independently within a company itself, or these can be frameworks, which is the commonly known frameworks, RAGAs, Promptful, Rectride, whichever you're using right now, or it can be human evaluation. So these are the different evaluation criteria that do exist. So for example, if you're looking at Helm benchmarks and all of those things, most of those can be compiled into all of these very specific categories. But there are limitations to each one of them. The human evaluation limitation, there are limitation to benchmarks, there are limitations to using large language models. So what are we supposed to do? First is, again, it's a hard problem. Defining good is hard. The benchmarks that do exist aren't really good enough. So what are we supposed to do? I say, think about how a RAG application works. So the way a RAG system does really work is you really have, so you basically have a user input. You're asking your model a very specific question, which is you're first retrieving the relevant information from a database based on the user's query, and then augmenting the query with snippets from the retrieved data itself. This augmented prompt is now fed into the large language model, which generates a response leveraging the additional context, ultimately providing like a more accurate and informative answer to the user's query. So that's how large any sort of RAG application works, right? Now let's look into this. What are you essentially doing in this entire process? You're doing two things. First, you're doing some sort of retrieval, and then you're doing some sort of generation. So instead of all of the evaluation metrics as a whole, break the evaluation metrics into these two categories. Break them into how good is the performance on retrieval itself, how good is the performance on generation itself. So in terms of generation itself, two of the main categories that people usually look at is the faithfulness and answer relevancy, which is making sure the model isn't really hallucinating. When it comes to retrieval itself, what you're looking at is the precision and the recall, which is how quickly is it able to catch the most relevant info. When it comes to retrieval metrics, but again, they're not just two. There are a couple of metrics you can look at within retrieval. So you can look at recall, you can look at MRR, you can look at MAP, which is the average precision of all of the documents which are being retrieved through the document. You can look at context recall, you can look at context precision, and you can look at context relevance. So I would say these are, on a high level, 6 metrics that you can look at when it comes to retrieval itself. What are the ones that you should be using? So I would say try to use all 6 of them as much as possible, which is you want to be able to evaluate your model on if it can catch the most relevant info very quickly, if the information that is being retrieved is relevant or not. How relevant is it to the context of the query itself? Does it align with the LLM's needs itself? So one of the easy ways to get started is using some sort of framework. So one of the frameworks I personally use very heavily is called RAGAs. One of the main reasons for that is there's a lot of pre-built functionality, which is a lot of metrics are sort of predefined. So context precision, context recall, those things are pretty much well defined within the Ragas library itself. You have a streamlined workflow. It's easy to use because it's a library. You just need to import Ragas and then you just start evaluating Ragas evaluators itself. Now, how to know what is the right tool that you should be using? So I would say Ragas would be the ideal choice to get started with. It's the basic first step to get started with when you're evaluating the retrieval component of your RAG application. Once you're at that point where you want to expand on that further, look into RAG-Tried, which is now you're adding human evaluation visualization on top of it to be able to do a little bit more comprehensive assessment of the evaluation that you've already done. The next step after that is using something like Llama Index, although I know Llama Index isn't primarily made for evaluation, but especially when it comes to private data, there are a lot of tools that are available, which aren't really reliable when it comes to like the more open source libraries, because anytime you're doing evaluation, the information is going up online. So sometimes you just need a little bit of privacy with your evaluation itself, especially if you're working on models where you have a lot of data, which you're not okay releasing, even to the model providers and the library providers itself. Then another one which I've been playing very heavily with is Promptful. Though not an evaluation tool directly, but it's sort of like an indirect tool for exploration and refinement. So that's the tool you use ideally when you're trying to optimize or trying to do fine-tuning on the model itself and trying to see if the performance is working or not. And finally, there's LangChain Evaluator, which is Langsmith Evaluator. So Langsmith, again, has a lot of predefined functions that you can use. So that would be the framework, or that would be the way to go about evaluating like the retrieval aspect of things. Now let's go to the next thing. But before we do, one thing we need to ask ourselves is, although we've defined what frameworks do we use, how do we define good, which is, yes, it will generate a couple of values. It will generate us something called recall. It will generate us something called MRR. What's a good value? What is the value that you should be aiming for? So I would say when it comes to recall, which is how much data is it able to retrieve within the query itself, you're looking at a general threshold range of 0.7 to 0.8 when it comes to the reciprocal rank. You're looking at 0.5 to 0.7. Ideally, though, it would depend on your task itself, or it would also depend on how much data do you have within your particular domain itself. So while, though these are sort of like benchmarks to have, good to have, but again, these would vary depending on the model itself, depending on the domain itself. So I would say aim for these, but don't think, okay, if I've got 0.4 on MRR, but I'm working on a climate change problem, then it's bad. Probably may not be really bad. But again, you can aim for that. When it comes to generation metrics, there are a couple of metrics you need to look at. Most of the frameworks that you're seeing in the market right now are just the retrieval frameworks. But one of the missing aspects that they don't really measure is the generation part. So in generation, what you're really measuring is the accuracy. You're measuring fluency and coherence. You're measuring relevance. You're measuring engagement. Again, these are very hard things to measure as well. So there are a couple of ways to be able to measure them. I would say broadly, you can sort of break them down into three categories. The first is using some sort of something called n-gram-based metrics. So you're looking at n-grams, basically the 1 gram and 2 gram, where you're looking at two sentences, two tokens, sequences of n number of words itself, to be able to evaluate your text data with the existing text data, which is generated text data, to be matched against the existing text data, to see if the data which is being retrieved is accurate or not. So in this particular category, you have three more popular scores, which is the Blue score, the Rogue score, and the Meteor score. These were very heavily known within the conventional NLP literature as well. Although I would say these are not super reliable, which is it's not a comprehensive set of evaluation metrics as well. What you also need beyond n-gram metrics is looking at similarity-based metrics, which is you want to assess the quality and the coherence of the generated text as well. How do you do that? You compare your large language model against another NLP model itself. So that could be a BERT model. If you compare it against BERT, then that's essentially what's called BERT score. Then you can also compare it against other NLP models, and that's basically called their score. But two of the really good scores that you should be looking at when it comes to looking at similarity-based metrics are SEM score and Moore score. So one is measuring how much the generated text moves semantically from the reference. So basically, you can think of it in terms of displacement itself, which is how much displacement is there between the generated text and the existing text or the reference text itself. And the SEM score is semantic similarity measure, where you're measuring the semantic similarity between the generated text and the reference text using your pre-trained language model itself. So I would say those are, although there's word perplexity and there's perplexity reduction, which you can also measure, but I would say those three are sort of super important to sort of get started with, which is start with BERT score, SEM score, and Mover score always. And then there are LLM-based metrics as well. This is the third broad category of how do you measure the generative ability of a model itself. So here we have a couple of metrics. So for example, there's G-eval, Uni-eval, there's GPT score, there's True. So there are quite a few of them. Each one of them is looking at different things. So for example, the G-eval, it's looking at the coherence, fluency, and factual consistency, as judged by another large language model. So Uni-eval, it would again look at those things through an ensemble of LLM evaluators itself. GPT score, it's designed for GPT-like model, so it wouldn't really work on an encoder-decoder model. It would work really well for decoder-only models. But again, the next part is, okay, if we know what are the things we need to measure, how do we know what's good? So when it comes to the n-gram-based metrics, I would say a 0.8 plus score of Blue is really good. When it comes to the Rogue score, which is when you're measuring the recall ability of the model itself, then a score of 0.6 plus is generally considered like good quality or high quality generation text itself. Meteor score, typically, though it would entirely depend on, so for example, on coding task where you have plenty of data, ideally you would be aiming for a higher score, but on an average across domains, typically a score of around 0.2 plus would be considered ideal. When it comes to model-based metrics, you should ideally be aiming for like a BERT score of 0.8 plus. The SEM score and Mover score, these would depend on the task and the desired quality level itself. So ideally, having a Mover score which is lower is ideal because you don't want the relevant text and the generated text to have moved a lot, which is you don't want too much displacement between them. So ideally you want them to be lower, but again, would depend on the domain itself. When it comes to LLM-based metrics, these would again depend on the task itself and the desired quality level. But one of the reasons that we're discussing this is really is thinking about evaluation a little bit more systematically, which is you know what you're measuring. While it's perfect to be able to look at a model and say, you know, my model is generating really good quality, I'm able to have conversations, but how do you measure the quantitatively. That's something that you can present to the teams. That's something you can agree on as KPIs. And that's the point where you can say, I think we need to switch to a different model for precisely this and this reason, because you're able to justify what's not really working. So that's one of the key reasons why we're measuring good over and over again. What are the open challenges? So I would say there are quite a few challenges. It's very hard to be able to judge the knowledge and the capacity of the model itself in the long range. It's very hard to be able to judge the domain specialization. Alignment is, again, one of those things which is hard to be able to evaluate. Safety is hard to evaluate. Though one of the things you can evaluate is essentially the training loss, which is basically you can measure the evaluation versus loss to see how the model is learning during training. So this is something which has been conventionally done by most ML learning teams itself. So this still remains one of those really good criteria itself. And this is the point where you think of early stopping. This is the point where you think of, can I do batching? What kind of data do I need to discard? So this is very much in the training phase itself. Once you pass the training phase, then ideally you're looking at the metrics that we were looking at earlier, which is the very specific retrieval and generation metrics itself. What are the limitations? Most of these are static benchmarks. So the glue score, the super glue, these are the ones which you would see papers about, which is super glue is one of the most popular ones. HLSWAG, a lot of really fun benchmarks have been evaluated on this. But I would say most of them are static, which means basically nothing's changing. They don't know what has changed in the world, so they haven't been updated for like months and months. So I would say probably not use the static benchmarks if possible. Then there are a few other limitations with those ones, which is there's data leakage problem, there's limited task scope, because these benchmarks are created on like very specific tasks for research purposes. Specifically, most of the knowledge within these benchmarks is outdated. Again, let's say if you're training a model for current events, it's not going to work as well. And the difficulty is limited as much as people are trying to improvise these existing benchmarks. So one of the organizations that working very heavily, which not an organization, I would say it's a team of volunteers that runs a website called MLSys. So they put out these benchmarks on which they sort of evaluate all of the new models that come in. The other thing they do is they ask people from the community to randomly vote on the model performance itself. So it's a not super reliable metrics. What are the open challenges? So the prompt sensitivity, there's this paper that came in, I think sometime last year, which is how is ChatGPT's behavior changing over time. A very interesting paper. What it basically said was there's a decrease in how the model was performing, which is there was model degradation between March and June 2023. As the company started working more heavily on the alignment and the bias reduction, toxicity reduction as well, the willingness to answer sensitive questions was also sort of decreased. And that means basically anything which according to them was defined as sensitive is a little bit hard to be able to do. So again, evaluation becomes super hard on those things as well. Then there's decrease in the model performance, decrease in accuracy. So the model changes behavior. I think this is pretty much obvious, which is the models are going to degrade over time, but the hard part about this is how to design prompts that are able to elicit, especially if you're building prompt engineering pipelines, then how to be able to build prompts that are able to change themselves with a period of time. And though there's a library, DSPY, to be able to do that, which is create automated prompts. But it's still, I would say, very much limited in what it can achieve. So most of the models are still very sensitive to the prompt itself. Construct validity. So this is another paper which I would probably recommend everybody reading, which is The Dangers of Trusting Stochastic Parrots. So what this paper basically explained was large language models are very sensitive to input, which is based on the input variations, the model behavior can be very unpredictable, which means anytime you're building like an end-to-end pipeline, automated end-to-end pipeline, it becomes really hard to be able to do. And so you need to have really strong evaluation metrics and monitoring in place to be able to catch things or unpredictable behaviors very quickly. And then reproducing them is equally hard. So for that reason, the most ideal thing is log as much as possible, log as many things as possible. But still, if the model performance is degrading over a period of time, sometimes it can be very hard to be able to reproduce the same text that was generated earlier. So factuality and hallucination, large language models, I would probably say I'm confident enough, which is as much as you can reduce the hallucination, you cannot fully remove it. And that's something that they're going to continue to struggle with. But again, I would say that's more like a feature than a flaw in the long run. So it depends on the kind of domain you're in. If you're looking for it to be able to generate accurate information about something where you cannot diverge, it's bad. But if you're looking at something in domains like creativity, for example, copy generation, it's fantastic. So think very, very carefully. Another paper that I would recommend everybody to read is Generalization or Memorization. This is a study on if large language models are learning, essentially, or are they memorizing a lot of information? Because again, they're being fed up with so much information. So this paper basically did some evaluation, and what they observed was while the models can appear smart by mimicking the language patterns, but essentially they do not grasp the meaning, which is pretty much understood. Then n-gram metrics miss the point. And this is precisely why I said, while n-gram metrics are fantastic as some starting evaluation metrics for like to be able to test the generative capabilities, but ideally you still want to look at semantic scores. Those are a little bit more reliable. So looking at SEM score, looking at BERT score and mover score would probably be my recommendations over here. Reasoning evaluation is hard. So right now, I don't think there's many benchmarks to be able to evaluate reasoning because, again, the domain can be really huge. So that pretty much is my presentation. I have a few recommendations, which is ideally you want to do instruction scaffolding, which is break down the prompts into smaller prompts as much as possible. So you can reduce the drift as much as possible, and you can reduce the sensitivity of specific wordings in the prompt itself. Use semantic similarity metrics as much as possible. Think about data cleaning and filtering. Those are very helpful. And I'm not specifically doing it manually, but building automated pipelines. But that's something we can cover in like a separate presentation. So that's all.
All right. Well, fantastic talk. I don't think we have time to answer all the questions live, so maybe some of these you can answer offline, but we'll take one question from Mohammed, which came in early in the presentation. What are the best strategies for integrating and performing evaluations of LLMs within a CI/CD pipeline, specifically in the context of RAG?
So I would say use an automated framework like Ruggers or Langsmith. If you're really worried about the privacy aspect, then use Langsmith, or otherwise just use Ruggers. So that would be the get-go of getting started over there. and then simple define your own SIM score and MOVE score. Use them as the evaluation benchmarks within your CI/CD pipeline itself.
So we'll take a question from Jim, who asks, how do RAG systems prioritize the information retrieved and incorporated into the prompt's context, or do they? And how does the LLM recognize that priority?
So the way retrieval essentially works, or the way RAG systems essentially work, is they're calculating the similarity within the vector databases itself. So what you're looking at is the way information is being retrieved at all points in time is using a similarity score. This can be the cosine similarity score, which is usually the case. So while different vector databases would have different kinds of similarity scores and different ways of retrieving, but that's essentially how you're retrieving the information. And so those metrics are used as features by the large language model itself, and then the generation happens on top of them.
Cool. So we'll take one last question here, which is a follow-up from Mohammed, and I think you may have covered in your presentation, so maybe a summary is all that is required here. Additionally, how can we define and implement key metrics to determine whether a model should be deployed or not, ensuring it meets the necessary performance, reliability, and safety standards for RAG and information retrieval applications?
So what I would usually say is, should you deploy a particular model, is if you can very clearly define the KPIs of what are you, how does it add to the business itself? So breaking those things down within the application itself. So for example, when it comes to an e-commerce application, thinking of very simple stuff like on the landing page itself, if you have a chatbot, is it making recommendations? Are those recommendations being clicked on by the user? So how does it push the person from like within the sales funnel? How does it close those things? Those are usually the most important metrics other than these things, which is, these are fantastic for evaluating the model itself. But even if the model is performing and everything, doesn't really mean it would be profitable for the business, and profitability is where you ideally want to be positioned within the company itself.